Hi, 6th grade. Welcome back. Another video for today. We'll go back to the tissue box. Okay, so we started this whole video series talking about perimeter. We just talked about the distance around an object, and we talked about it being a flat object, right? So not three-dimensional, just flat. So three-dimensional meaning one dimension being the length, one dimension being the width. So not three-dimensional, two-dimensional. It has a length and it has a width. Okay. So if you add up the lengths and the widths, we found the perimeter. If it was a circle, we said if you find the circumference of that circle, that's the distance around the outside of the circle, which is pi times diameter. All right. Then we found the area, where we took length and we multiplied it by the width to find how much space there was like across the surface, okay? Across the middle of that surface. We said length times width is area. So if we did, I don't know, maybe inches and measured the size of this box in inches, and we multiplied the inches going up the other side of the box, if we multiplied and multiplied, then we would see how many squares that are 1 inch by 1 inch would fit in this area that you can see, okay? Including where this plastic is, okay, if it was all paper. How much would fit in there? Now, then we talked about volume. So then we were talking about a three-dimensional object. And instead of just having a length and a width to it, we added a length and a width, and we added the third dimension, which is height. So when we talked about volume, we talked about finding length and the width, but that's basically just like one layer along the bottom. And then when you multiply that by the height, it'll show you how many layers can fit inside the box, essentially. Okay. Now today we're going to talk a little bit different. It's called surface area, but I'm reviewing them because ultimately all 4 topics are going to be on your end of chapter test. So in your end of chapter test, you're going to have to know perimeter, area, volume, and surface area. Okay? So if you think surface, right? So if you think the ocean, the surface is obviously on top of the ocean. If you are talking about the surface of a counter, you're talking about the top of a counter, which is like the top of what you can see, right? So if we go back to the Kleenex box, okay, the thing is that depending on where I look at it from, whether I look at it from your view here, this would be a surface. But if I turn this object, you could argue that this is a surface, or that this is a surface, or this is a surface, or this is a surface, or that the bottom of the tissue box is a surface, okay? So this tissue box has 1, 2, 3, 4, 5, 6 surfaces, okay? It has 6 different surfaces that you are going to try to find the area of, okay? And sometimes it's really hard to find surface area of a figure like this because you have to look and you have to count them all up, okay? So what you can do, right, is if you can like unfold it in your mind. If I take this Kleenex box and I carefully try to tear it apart, right? Obviously these tabs on the edges don't count because they were just in there to hold the box together, and they were not on the surface. Same thing here. This tab was what the side of the box was glued to, so it was not on the surface, and this was not on the surface either. So I'm going to get rid of that. Okay. And if I can carefully take this apart somehow. Now I have my surfaces, basically, that I'm going to talk about. So, if you go to your packet, 577, the one that you got today, it says surface area of a prism is the sum of the areas of its forces. So if you have like you have a length, a width, and a height, just like we had with volume. Okay. So the surface area, I'm reading the key concept on the bottom of 577. The surface area of a rectangular prism with a length, width, and height is the sum of all of the areas of the faces. Okay? It's the sum of all of the areas in the faces. So it's the sum, like we were talking about the Kleenex box, there's 6 different faces. You essentially have to find those 6 faces and then add them all together. Okay? So let's look at example number 1, which is on page 578. So example number 1 on 578, it shows a rectangular prism. Try to make it look as much like the book as possible, or your packet, I should say, as possible. Okay, but it looks something like that. All right, and this is, I drew it out of proportion because this is supposed to be 7, this is supposed to be 5, and then this is supposed to be 4. Okay, so if I was finding the surface area of this box, okay, I know you told me to use darker colors, so I'm going to try to, let's see, this is 7, this is 5, and this is 4. But again, you can see it on your packet, example number 1, okay? But if I am looking at the, this front of the box, right? So if I fold my Kleenex box kind of back up together, and I have it kind of sitting at this angle, if I'm looking at the front of the box, which would be right here when it's all glued together, the front, right here, and the back should be the same. Front and back should be the same, okay? So I'm going to get another Kleenex box. I had to jam those Kleenexes in here so it would work. So just imagine this is closed up. But what I'm saying is this part of the Kleenex box and this part of the Kleenex box, the front and the back, front and back, they're going to be the same. What you can see here is that if you find the area is length times width. So the area of the front of this box right here is going to be 7 times 4, which is, I'm trying to find the dimension. 7 times 4, which is 28 feet squared, which means this is going to be 28 right up here in front, but it also means the back side is going to be 28. Now it's really hard for me to draw lines and for you to know exactly what is what, but each one should be 28. Okay, let me pull a little closer to see if that helps at all. All right, so then those are almost like given for you, right? But what you should know is that if this side here is 4, and I'm talking about my Kleenex box, here it is. If this side here is 4, basically, that's what's on the picture, then this side here should also be 4. So this one and this one should be the same. Okay? So if this is 4 and this is 4, then if I'm taking and I'm looking at surface area of this box, that means if this bottom is 5, this bottom is 5, that's what's showing me here. This bottom is 5, and this is 4, right? Because this is 4, that's what I have. Then 5 times 4 would be 20 and I'd be talking about the area of this surface here. Okay? So 20 feet squared should be the area of this surface right here on this side, and if it had its cover on it, it should also be the surface area of this side. Okay? So like the right side and the left side, or the left side and the right side, however you want to say it. But the two sides have the same area. So if this is 20, then this one over here on this side is also 20. Okay? All right. So we said there's 6 surfaces, right? So that means we know there's 2 of them that are 28. The front is 28 and the back is 28. We know there's 2 of them that are 20. The left is 20 and the right is 20. So the only thing that's left of this rectangular prism would be the top and the bottom. The top and the bottom. Okay? So we found this is 28, 28, 20, 20. Obviously, this box is not the same proportions as up there, but what we have left to find is the top and the bottom. So when we do that, finding the top and the bottom, I would say 7 times 5 is how much? Well, I would say it's 35. So if this is, again, it's not proportionately the same, but if this is 7 and this is 5, looking at what the dimensions are there, that means if I tip it upside down, 7 and 5, this bottom is considered a surface. Okay? So 7 times 5 is 35 feet squared. So down underneath the bottom is 35. And that also means that up on top it is 35. Okay? So if I wanted to find the surface area of everything, now I would have to add all 6 sides together. Okay? So I would say 35 for the top, 35 for the bottom. I would say 28 for the front, 28 for the back, and then I would say 40 for the right and 40 for the left. And if you add them all up, then you're going to wind up with your surface area. Okay? So what they did in your packet is they doubled them, right? They combined 28. They combined 28 and 28 to get 56. And they combined 35 and 35 to get 70. And finally, they combined, let me see, 2 times 5 times 4, 40. What did I do wrong? Oh, this shouldn't be 40 and 40. I did one step early. So instead of 40 and 40, this should be 20 and 20, because 20 and 20. And they combined it to make 40. Okay? And then, when they added it all up, they got a final answer of 166 square feet, or feet squared. Okay? So you already know how to do area, length times width. So what you just have to understand is that when you take and you break the box down, you have these different surfaces, but if you're finding the surface area, you're just trying to find the area of this flat, area of this flat, area of this flat, and then you're just adding all 6 sides basically up together. Okay? All right, so pause it if you need to, because I'm about to read the answer to check your progress A. So if you want to try it, again, it's a rectangular prism, so you should wind up with 6 faces. You have a 3, a 4, a 2, right? So I see that the 4 and the 2 are together, so there's going to be an 8. 4 times 2 is 8 for a couple sides. 3 times 4 is 12 for a couple sides. And then you're going to have to see the bottom one. But what I notice is if it's 4 meters on the top in that picture, then if you go straight down below it to the bottom where that back dotted line is, that should be the same. That should be the same. Same thing with 3 meters. 3 meters looks like the top. If you go down below it, that should be 3 meters as well. Okay? All right, so I'm about to tell you the answer. The answer for check your progress, letter A, should be 52 meters. It should be 52 meters. So why don't you give it a shot and see if you can come up with a surface area of 52 meters. Okay? All right, now, I don't know. I think I must be missing a page in my answer key here. I definitely am. But if you know how to do number 1 and you know how to do check your progress A, you're on a good start for what we do in class tomorrow. Okay? All right, we'll see you tomorrow. Thank you.